So what we have here is we have a urine sample that we're assuming exceeds the limits of the meters when first tested. So we have to dilute it and retest it. So we have a 200 microliter sample that is diluted with 1 milliliter of saline, of sterile water. So that means we have 200 microliters of our serum, or urine in this case, and the 1 milliliter has to be converted to 1,000 microliters of water. So we need to find our dilution that we created here. Remember, dilution is parts serum to total parts of solution. So for this case, we have the 200 microliters of the urine over, has to be 1,000 plus 200 for our total. So we'll add those up. Microliters are going to cancel out for us, but it's 200 over 1,200. And then both of those can divide by 200. So that reduces to a 1 in 6 dilution. So that's the dilution created here. Once we have that dilution, we can use that to convert our reading, our diluted reading, to a concentrated reading. Remember, our dilution, 1 in 6, is going to be equated to a ratio of the diluted level, diluted reading, to concentrated reading. So we have 1 in 6 is our dilution ratio. The 162 milligrams per deciliter is our diluted reading. And we can cross multiply and divide. 6 times 162 is 972, I believe. Divided by 1 will be 972 milligrams per deciliter. Any questions on those dilutions for making readings like that? Okay. Now, another thing that I want to make sure we have clear is for a 2 in 7 dilution, what is the ratio of serum to saline? Serum to NS. I'm going to give you guys just a few seconds to think about that and see what you come up with. See if you can jot down an answer. Okay, so the dilution given here is 2 in 7. But remember that 2 stands for the parts of serum, and the 7 stands for the parts of total solution. The ratio that we want is the ratio of serum to saline. So that ratio, it's still going to be 2 parts of serum. The parts of saline, however, if we have 7 total parts and 2 parts are serum, 7 minus 2 is going to give us 5 parts saline. So it's a 2 in 5 or 2 to 5 ratio of serum to saline. Okay, so that's kind of our review from Monday. The dilutions are really the heart of the first half of our dosage calculation unit here. What we're going to do today actually depends very heavily on these dilutions. What we did on Monday, we were taking a serum, which could be a medication, or it could be some bodily fluid like blood or urine, and we were diluting that pure substance with water. Which we abbreviated NS for normal saline, which is any sort of sterile water. Neutral solution is another way to think of it. Well, today what we're going to look at is what if we have a solution? Remember that solution is already a mixture of some sort of serum and a diluent of water. And the concentration remember, we can find the amount of serum, of substance, of active ingredient is found by taking that concentration times the total volume, which gives us the amount of serum. So we're going to use our dilutions here today to take that concentrated solution, which we're going to call a concentrate, and we're going to dilute it even further to get it to a lower concentration. So let's take a look at how this all works. So what we're looking at here, our dilution now, if we say that we have a 1 in 5 dilution, that is no longer referring to 1 part of serum, it's 1 part of concentrate to total solution now. So let's take a look. Let's say we have 240 milliliters of a 48% solution. We're going to mix it with 120 milliliters of NS, neutral solution. Find the new concentration. Okay, so what we have here is we have 240 milliliters of 48% solution. Let's find the amount of active ingredient. The amount of our active substance there. If you recall from our solution mixing equations, that's simply going to be 48%, 0.48, times the volume, 240 milliliters, is going to equal that amount. So 0.48 times 240, I believe, is 1152, but let's punch it in to be sure here. Get this out of the way. So 0.48 times 240, oops. 115.2. So that is the amount of, in milliliters, the amount of the active ingredient, or whatever the serum is that we are using here. Well, we're now finding a new concentration. We are adding 120 milliliters of 0% to that. So our total volume is now going to be the 240 milliliters plus another 120 milliliters, giving us 360 milliliters of total volume. Well, we still have only the 115.2 milliliters of active ingredient. So our new concentration times that new volume of 360 equals 115.2. We can solve this for our new concentration by dividing by the 360. So we So divide this by 360, gives us 0.32. So our new concentration is 0.32 or 32%. Now I did that as kind of a roundabout way because what we were adding here was water, was normal saline. There was no medicinal value. We didn't have to do out the formal solution mixing equation, but we could have. We could have taken that we were combining 48% with 0% to get some unknown concentration. And that we were combining 240 milliliters of the 48% with 120 milliliters of 0%, that would be our water, normal saline, and that better give us a total, 240 plus 120, of 360 milliliters. And we could have done out our formulas just like we did in Unit 2. 0.48 plus 240. Notice that's kind of what we did up above, plus 0 times the 120. There was no active ingredient, no serum added from the water that we added. 2, we'll let X be that new concentration, X times 360. So you can see this calculation comes out exactly like what we did up above. This is 115.2, that's 0, equals X times 360. We divide by 360 to get that 0.32. So it reduces to a 32%. Well, we can do a similar thing here. If I want to say we have a 60% solution and we perform a 2 in 5 dilution on that solution. Find the new concentration. Well, the one thing you can see that is noticeably missing here is the volume of that original 60% solution. The answer is it doesn't matter, but let's take a look and let's just assume a volume. Assume a volume of 300, well, we can pick whatever. I'm going to use 300 milliliters of the 60% solution. We could have chose 100 milliliters, 1,000 milliliters, whatever we wanted to. So what that tells us now is out of that 300 milliliters, 60% or 0.60 concentration times 300 equals 180 milliliters of whatever our serum is, our active ingredient. Now we have a 2 in 5 dilution. The 2 represents the concentrate. The 5 is going to be the total solution after the dilution. So as we match those up, we have 300 milliliters total before we diluted it. That's what we chose to use. We can find the volume after it's diluted. 5 times 300 divided by 2, it'll have a total volume of 750 milliliters after it's diluted. So we can use that now to find the concentration. We have our new concentration, C or X or whatever you want to use, times that new volume of 750 milliliters equals, well, we still only have 180 milliliters of our active ingredient, of our serum here. If we divide this by 750, 180 divided by 750 gives us 0.24. So it is now diluted to 24%. And we can do a similar calculation with this of, we have a 24% solution. We need, let's say we need 480 milliliters of a 6% solution. So I want to know how much 24% solution and how much water, sterile water, saline, to combine. So this is a quite a bit more complex problem than the first couple of examples we've looked at. So we're looking at this, we have a 24% solution. We need 480 milliliters of 6% solution. So we're going to write that out. 6% times 480 milliliters means we're going to need active ingredient 28.8 milliliters of active ingredient. Well, we can use that now to figure out how much 24% solution do we need. I'm going to do 24% is 0.24 concentration times volume. I'm going to put volume with a little 24 by it. That's the volume of the 24% solution. Has to give us that 28.8 milliliters of our active substance here, active ingredient. So to find the volume of the 24%, we're going to divide by the 0.24. So the volume of that 24%, 28.8 divided by 0.24, gives us 120 milliliters. So we need 120 milliliters of the 24% solution. Which means we need 480 minus 120, or 360 milliliters of sterile water added to that, saline. So now the question is, what dilution would that be? The dilution would be, we have 120 milliliters of the concentrate, that's the 24%, over not the 360, but the 480 milliliters of total volume. The milliliters cross off. Both of those actually do divide by 120, giving us a 1 in 4 dilution. Well, we've been doing these the long way. Let's look for the shortcut. Let's say we have 120 milliliters of 36% solution. We perform a 1 in 9 dilution. So I want to find the new concentration. So I've got a dilution here of 1 in 9. We're not going to do anything with that for now. We're going to come back to that. We have 36% solution times 120 milliliters, which is going to give us, I believe, 43 0.2 is correct. 43.2 milliliters of that active substance. Working backwards now, after a 1 in 9 dilution, our new volume, we had 120 milliliters. Our new total volume should be 1,080 milliliters. So our new concentration here, we'll do the C times 1,080 milliliters has to still equal 43.2 milliliters of our active ingredient. So 43.2 divided by 1,080, we get 0.04. .04 or 4%. Now let's go back here to our original dilution here that we had. We had a 1 in 9 dilution. The concentrated percent was 36%. The diluted percent was 4%. We noticed that if we put those into this proportion, if we put the diluted percent on top and the concentrated percent on bottom, that ratio of the after to before, the diluted to the concentrated, is the same as our dilution ratio. That's why when we do a dilution ratio, it is serum to total rather than serum to saline. So if I dilute 300 milliliters of 64% solution with 900 milliliters of saline, we're asked to find the new concentration. Rather than going through our solution, formulas, we can actually just look at, okay, we have a dilution formed here where we started out with 300 milliliters of our concentrate, our more concentrated formula. We have a total of 300 plus 900 milliliters. Canceling out the milliliters, we've got 300 over 1,200, which reduces to a 1 in 4 dilution. We can now use that 1 in 4 dilution to adjust our concentration. 64% is the concentrated. We're looking for the diluted percent on top. We cross multiply. 1 times 64 is 64. Divided by 4 is 16. So our new concentration is 16%. Now I get asked all the time, shouldn't I list this as 0.64 as a concentration? And that wouldn't matter. If I did that, I would cross multiply and divide and I'd get 0.16 as my new concentration, which would be adjusted, again, converted to a percent is 16%. So it doesn't matter whether we use this as a percent or as a decimal, a rate, as long as we do both in that. Whatever we have for a decimal here, this will be a decimal, or if this is a percent, this will be a percent. And we can use it the other way. We can ask how much saline should be added to 150 milliliters of 21% solution to dilute it to, let's go 14%. So again, the dilution we create here, we don't have the volumes anymore. We're looking for the volume. The volumes is going to be the volume or the parts of concentrate compared to the total parts. We don't have that. We have the concentrations. So we're going to have the diluted concentration over the concentrated concentration. So the concentrated concentration, the higher percentage is 21%. On bottom, the diluted percentage is 14%, and that reduces to 2 to 3. So that means our ratio here of concentrate to total has to be 2 to 3. We have a volume of 150 milliliters of our concentrated solution. We cross multiply and divide. 3 times 150 divided by 2 is 225 milliliters. Now that 225 milliliters is the total solution. So we do still have to subtract. We need 225 milliliters total. We're going to subtract the 150 milliliters that we already had of the 21% solution to get that we need to add 75 milliliters of saline. Now this proportion up here can get kind of confusing because you'll notice the 21% goes on bottom in our ratio of concentrations, but the concentrated volume goes on top. That's the 150 milliliters. So even though the 150 milliliters is the 21% solution, they don't go in the same spot in this proportion. We've talked about we always have to line things up in our proportion. But in this case, this is what's called an inverse relationship, inverse variation. And an inverse variation, when the concentration gets smaller, the volume has to get larger, as long as we're not changing the amount of that active substance. So because of that, because it's an inverse relationship, the amounts are not proportional. So the amounts will not, the relationships will not line up. So we just have to go off the label. In our dilution, which compares volumes, the concentrate is on top and the total is on bottom. In our ratio of concentrations that equals the dilution, the diluted percent is on top and the concentrated percent is on bottom. Which leads us to another formula, which kind of ties in with all this. This is our concentration adjustment formula, or change of concentration formula. And what that is telling us is the amount of the active substance before we dilute a material has to equal the amount after we dilute a solution. So what that's saying is the amount of the active substance before. Let's put some numbers in here. Let's say we have 120 milliliters of 33% solution. We're going to dilute it with 240 milliliters of NS. So before, we have 33% times 120 milliliters. After, because that's going to give us an amount of active ingredient there. If we figure that out, that's, I believe, 39.6. It is 39.6 milliliters, which is what we did up above before we used our shortcut with our dilutions to just the percent. Well, after we dilute it, we're still going to have that same concentration, or same amount, sorry, not concentration, but same amount of the active substance. The concentration will change because the volume changes. So this new concentration, I'm going to call it C2 for the after concentration, times that new volume, which is 120 plus the 240, with 360 milliliters, has to equal that amount of active ingredient. So to solve that, I would just divide by the 360 milliliters, and that should give us 0.11. It does. So 0.11 is our new concentration, so 11%. We notice what we had here is we had an initial concentration times an initial volume, which gave us a final concentration times a final volume. And we can write that as C1 times V1, that's the first concentration times the first volume, equals C2 times V2, the second concentration times the second volume. Now, just like we did before, we saw up above with our ratio of concentrations and our dilutions, C1 and C2 can either be written like we did here as decimals, or we could just leave them as percents, as 33 and 11. Let's do an example using that formula. Let's say that we want to dilute we want to dilute 480 milliliters of 12% solution to 10%. What will the volume of the final solution be? What will the final volume be? So we start out with 480 milliliters of 12%. So I could put that as 0.12, or I could just leave it as 12. I'm going to leave it as 12 just to make it easier to work with. So that's 12 times 480 milliliters. That is concentration before times the volume before. Equals, that's going to have to equal the concentration after times the volume after. Well, the concentration after, we want it to be 10%. So since I left this as a 12, I'm going to leave that as a 10. And I am looking for that final volume. So I put in the amounts here. 12 times 480 is 5760. And then we'll divide by the 10. So that's 576 equals that final volume. So the final volume is 576 milliliters. Now, similar to that, but just a little bit different, we might ask, how much saline do we need to add? So let's say we have 180 milliliters of a 72% solution. How much NS should be added to dilute to, let's see here, Let's go 27%. Well, now again, we could use that dilutions. We know that our dilution here, if we use the percents rather than the volumes, would be 27 over 72, which reduces to a 3 and 8 dilution. So we could actually use that to compare our total volumes if we wanted to. But we're going to use this change of concentration formula, where concentration 1 times volume 1 has to equal concentration 2 times volume 2. Our original concentration is 72% times our original volume of 180%, or 180 milliliters, equals, we want our new concentration to be 27 milliliters, we want our new concentration to be 27%, sorry, times whatever our new volume is. So we calculate 72 times 180 is 12,960 equals 27 times V2, and we'll divide by 27. We get 480 equals V2. Now we have to make sure we've answered the question. The question was how much saline should be added. What we found is the total volume of 480 milliliters. That's the volume after we diluted it. To get the amount of saline, well, we started out with 180 milliliters, so the difference must be what we added in saline. 480 minus 180 is 300 milliliters of saline. Similar to that, we might have a question like this. Find the new concentration if 240 milliliters of saline is combined with 360 milliliters of 18% solution. So again, we're going to use that concentration times volume before equals concentration times volume after. We have, starting out with, we have 18% times 360 milliliters equals, we don't know our new concentration. It will not be times 240 here though. It's got to be 240 plus 360 because we added 240 milliliters of saline to an existing 360 milliliters of solution. So this is 18 times 360 equals our new concentration times 600. So now we'll multiply that out. 18 times 360 should be 6480. You got it. And then we divide out the 600. Gives us 10.8%. Is our new concentration. That is what we were asked to find there. Find the new concentration. Now you can see this formula here, this concentration adjustment or change of concentration formula, actually comes from our dilutions. You know, we showed how it could actually come from our our solution formula, concentration times volume equals amount of active ingredient. But it also equates to our dilutions. Remember, our dilutions by volume or by parts is the parts concentrate, which is the volume, the first volume, to the total volume, which is our second volume. But if we're looking at it as far as percentage or concentration, it is the diluted concentration, the second concentration, to the original concentration, or the concentrated percent. And if we look at that proportion, if we multiply, if we cross multiply here, we have V1 times C1. In this direction, we have V2 times C2. Those have to be equal. Doing some rearranging, I'm going to put C1 first. This has to be equal to that. So you can see that adjustment or concentration adjustment or change of concentration formula is consistent with all of the things we've learned, the dilutions and our amount of active ingredient in a solution formulas. So that leaves you with a lot to practice for now. There are going to be some pages I want you to work on. Pages 134, problems 1 through 11. If you just do the odds there, that'll be fine. And page 138, problems 1 through 17. Again, if you just do the odds, that'll be fine. So working with these couple of formulas, again, the dilution, if I have a 45% solution that goes through a 2 and 9 dilution, the new percent can be found off of that dilution. Remember, the 45 is the concentrated percent. Excuse me, cross multiply and divide. 2 times 45 divided by 9 is going to be 10% will be the new solution. Or again, the change of concentration. C1V1 equals C2V2, which would give us the same amount. We could actually put that 2 to 9 dilution in as our volumes. The 2 is the initial volume, the 9 is the final volume. So we could put 2 times 45%, oops, sorry, the concentration should go first. The 45% times the volume of 2 equals our new concentration times the volume of 9. And we get the same result. Notice it's the exact same calculation we did up here. 45 times 2, and then we would divide by 9 to solve it. Okay, so those 2 pages, work on those for Friday, and we'll talk more about concentrations and solutions on Friday. You guys have a great day.